Welcome to the session on straight line graphs, length and area. The objectives for this session are to solve length problems on coordinate grids and also solve area problems on coordinate grids. The distance between 2 points a equals x1, y1 and b equals x2, y2 is d equals the square root of the length of the x side, all squared, plus the length of the y side, all squared. So clearly this is square root of x2 minus x1, all squared, plus y2 minus y1, all squared. Let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So example 1 requires us to find the distance between the points 3, 2 and 7, 5 as shown on our graph. So length squared or d squared is as shown. The difference in the x coordinates all squared plus the difference in the y coordinates all squared to give 4 squared plus 3 squared. Therefore d squared is 25 and therefore d is equal to the square root of 25, which is of course 5. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So we let L1 and L2 be straight lines. Suppose L1 has equation x plus 3y minus 11 equals 0 and L2 has equation x plus y equals 5. Now, L1 and L2 intersect at point A. Also, B is the point where L1 meets the x-axis. Find the coordinates of A. And secondly, calculate the area of triangle AOB. So let's solve example 2a first, where we are required to find the coordinates of A. We substitute the equation L2 in equation L1 in order to find the point of intersection. So the equation L1 is of course x plus 3y minus 11 equals 0. L2 rearranged is x equals 5 minus y. So let's substitute 5 minus y in equation L1. Here. To give 5 minus y plus 3y minus 11 equals 0. So adding up the y's, minus y plus 3y gives 2y. And adding up the constants, 5 minus 11 gives minus 6. So we have that 2y is equal to 6. Dividing through by 2 gives that y is equal to 3. And now we can substitute this in the equation L2. So x equals 5 minus y, or x equals 5 minus 3. And therefore x is equal to 2. So the point A is equal to 2, 3. Now for example 2b, we are required to calculate the area of triangle AOB. Let's plot these two lines in order to understand the scenario a little better. We also have on our graph the point O, the origin, the point A where the two lines intersect, and of course A is equal to 2, 3, and the point B. This is the point where L1 meets the x-axis. The The height of the triangle is 3 units, since A is equal to 2, 3. Since L1 meets the x-axis at B, we can put y equals 0 in our equation to find the x-coordinate. And therefore substituting y equals 0 in this equation gives us x plus 3 times 0 minus 11 equals 0. And rearranging gives x minus 11 equals 0, or x equals 11. And therefore we have some of the dimensions of our triangle. We've got the base as 11 units and the height as 3 units. The area of a triangle is half base times height, and therefore inputting the base equal to 11 and the height equal to 3 gives us that the area of the triangle is half times 11 times 3, which is 16.5. This brings us to the end of this session. If you have understood its contents, you should be able to solve length problems on coordinate grids and solve area problems on coordinate grids also. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.